Here we're to graph this piecewise function. So what we're going to do is graph each part of the sections. So let's start with if x is less than 1. So I'm going to start out by plugging in points. Now we should be able to tell by looking at this is linear, so we have x plus 1. So I'm going to have x and 1. So I'm going to start out by placing 1 in for x. And then what's less than 1? 0, negative 1. So I'm just going to pick 0. So here's what I'm going to do is I'm going to take x plus 1, I'm going to plug in 1, so I get 1 plus 1, so I get 2. Okay, I'm going to do the same thing, I'm going to plug in 0, so it's going to be 0 plus 1, or 1. So we're going to graph that part. Alright, so let's go ahead and plot point 0, 1. We know that's on our graph, so 0, and then up to 1. So that's a point for us. Okay, and then for this, when x is 1, okay, y is up at 2, okay, but it's going to be open for this part since it's not equals to. And so we'll just draw basically a line, something like that. It should kind of split there, but you get the idea that we have a linear and it's positive. So we would say that this is increasing. So this would be increasing for that part of our function. Now, for 2 from 1 to 3, we have it y is equal to 2. So what we'll do is I'm going to take away that for right now, and we're going to have a straight line connected to it to there. Okay, so that's going to be constant for that part, would be constant. Okay, now, so it's equal to there. Now we have to see what happens here. Now what I'm going to do is I'm going to plug in points again. I've got x and y. So what I'm going to do is take 3 and plug it in there. So I get 3 minus 3 is going to give us 0 plus 2. So when I plug in 3 for x, okay, I'm going to get 0 plus 2, so I'm going to end up with 2. Okay, and then I say, well, what's greater than 3? Well, 4 is. So let's do 4. So 4 minus 3, so I get 1 squared plus 2, so I'm going to end up with 3. Alright, now what we have to be careful here, this is a quadratic, so it's not going to be a straight line, it's going to be a curve to it. Okay, so here at 3, we're at 2, so we're here. Okay, now when we're at 4, we go up to 3. Okay, and so what we're going to end up with is a curved line. Well, that's a little bit flatter than I'd like, but anyway, we get a curved line coming up like this, so that's the quadratic part. Okay, and so we're increasing again. Now, for these, we don't have any open circles because the graphs are connected where they would be open. So here, where one graph stops, the other graph takes off. So there's no points of discontinuity. Alright, now for question 2, we're going to graph a step function. So it's, there's going to be places where the graph doesn't exist. Let's start out with the first part. Okay, so from when x is 0 to 2, y is equal to 1. Okay, now it's not equal to here, so we'll put an open circle, and then we'll go to 2. Okay, now we're equal to here, so let's go ahead and fill in that circle. Okay, then once we get to 2, once we get to 2 point whatever, it's going to jump up, and so when between 2 and 4, we're up at 2. Now, again, it's not equal to, so it's going to be open. Okay, then we go to 4, and we're going to close it in because it's equal to. Okay, and then finally we'll do the same thing when we're at 4. I'm sorry, I left off part of the graph. Hang on, let me fill this in. Alright, so we're going to have to redraw this. Now we're good. That's fine. Okay, then when we're at x equals 4, we jump up to 3. Okay, that's going to be open. Okay, and then from 4 to 6, okay, it's going to be connected, and then it's going to be filled in. Then we're going to run out of space on this graph, but we'll just continue. Okay, so 7, 8. So from 6 to 8, okay, we're going to end up with a similar part, but we're going to be up here at 4. Okay, and so that's what our graph should look like. So why all these would be considered constants? Okay, because there's not an increase or decrease. We're just staying level for that part. All right, here we're going to write absolute value as a piecewise function. And so the way we're going to do that is we're first just going to start out with the positive part. Okay, so when x is positive, we're going to be on this side. Now we should know what the graph looks like from this. So let's go ahead and grab it because we know an absolute value function. We can put in points. Let's go ahead and put in some points just to show, but you don't have to do this because you should know what this looks like. Alright, so if I put in 0, I get out 0. So that's going to be our vertex, be here at 0. If I put in 1, I get out 1. So that would be here. Well, if I put in -1, I get out +1. So that'd be here. And we could keep going, and so we should end up with a V-shaped look to it. Well, it's kind of, I kind of wiggle on the line. Alright, so let's go something like this, and we keep going on forever. Alright, so it would increase from here to there to 0, and then from 0 to infinity it's going to increase. So decrease, increase. So this would be a decrease, this would be an increase. Alright, but let's look at how we'd come up with the thing. So for this part is where x's are positive. So when x is greater than 0, okay, we're going to use just x. Okay, but then what we have to do is take the negative of this, so we take the negative x. Okay, so when x is less than or equal to 0, okay, we're going to use negative x. We could put the if with this. So if x is greater than 0, it's this. If x is less than or equal to 0, it's this. Okay, so we've written it as a piecewise function and graphed it. Alright, for 4, we're supposed to write this as a piecewise function. Actually, this says graph the absolute value and then write it. But let's go ahead and graph it. Now remember, the +2 moves it up 2. Okay, so we would come up 2 for the +2. And then the -3 is going to actually move it to the left. 1, 2, 3. Okay, so that would be our vertex. Okay, so again, our vertex is going to be, sorry, that should be to the right because it's opposite. So it'd be here and then over 3 up 2. So that's our vertex. Our vertex is 3, 2. Okay. And then we could plot points, but we know that we should get our little V shape going. So we should have a graph that looks like this. And if we wanted to check where this is 0, we could plug in 3, that becomes 0 plus 2. So we're good. So that's our vertex. Now to write it as a piecewise, remember as a piecewise, we're going to say, okay, when is the absolute value part 0? So we add 3, so x is 3. So that's going to be our ifs. So I'm going to write it over here. So as a piecewise function, okay, if x is greater than 3, it's going to be this, and if x is less than or equal to 3, it's going to be this part. Now to come up with the first part, we're just going to take this out of the absolute values and combine. So what we'll do is say x minus 3 plus 2. I've got -3 plus 2, different signs, subtract. So I end up with x minus 1. Okay, so that's if x is greater than 3. Now if it's less than, we have to see the negative. So we're going to multiply the absolute value by -1. Alright, make sure you distribute this through so that we end up with -x plus 3 plus 2. So now it's going to be 3 plus 2 for 5. So we get -x plus 5. Okay, so that's the piecewise function. And now the vertex in this case would be a minimum because that's the lowest point. If we had been reflected and we had a negative here, it would have been the maximum. So this is a minimum point.